Hello. Welcome everyone to Q&A for day two. What a great lineup of talks today. Uh, just a reminder to all our audience members, please add your questions on the Q&A box that you'll see on the right of the video window. As we go through the questions, we'll bring your questions to our talks for today. So let's get started, starting with Sam. Impressive work on Sam 2, Chay. How well can Sam 2 support long videos? Have you tested this? Do you feel confident of Sam 2 supporting long videos as well?
Yeah, thanks for the question. So, in terms of benchmarks, SAMTO actually delivers a step change in performance on long video object segmentation benchmarks. So, for example, on LVOSV2, SAMTO shows a plus 16 point GNF score versus the previous best reported performance. Um, but benchmarks aside, remember that Sound 2 is an interactive model. So if there's a mistake on a long video, all it takes to recover performance is just a click or two. With that being said, performance on how do we handle long videos is really a standalone research question on its own. And there's like challenges along like the task model and the data axes. Just from the task perspective, long videos typically tend to be more challenging. So some performance gap versus shorter videos is to be expected. From the modeling perspective, longer videos means like a bigger shift from the training setting. So again, a little bit of performance gap can be expected, but there are ways to mitigate this. Like SAM 2.1, for example, introduces modeling changes that benefit longer videos more than shorter videos. And then also from the data axis, like having more long data will be helpful. And so, and this is part of the motivation for us also to release all of the things that we did for the open source, which is the training code, the data, and the model, and the demo code. So what that does is it makes it really easy for people to go out and fix some of the issues, whether that's on long videos or anything else, collect some more data. We're trying to make it as easy as possible to build on top of SAM2.
That's great. What you mentioned a lot during your presentation that performance has been a big part of uh, current work, but as well as the next steps with 2.1 as kind of the future area of work. What are some of the kind of biggest challenges remaining to be solved? Is it just performance, or are other areas do you think is accuracy or other areas continue to be a challenge?
Yeah, good question. So I guess so we've made a lot of progress, but there's some challenges that are still there. Um, I've highlighted some of these in the talk. One is when there's a lot of similar looking objects and there's a lot of fast motion and the objects can include each other. This is a pretty challenging situation. Um, but then there are, I think, like fairly low hanging paths forward. Like we can rely more strongly on motion cues. Classical approaches for this has been stuff like Kalman filtering on bounding boxes. This was a pretty popular way to do stuff like this, and things like this could help here. Another challenging open question is like using natural language for this. This is a very challenging problem because there's a very long tail of concepts, right? And they can have many different kinds of attributes. Um, and then long videos, as we just discussed, is an area where there could be room for progress. Fine details is something that, again, there's like a room for improvement. Um, yeah, but really excited about what kind of progress that is possible from the community on top of this. Looking forward to it.
Yeah, that's great to hear. I'm sure there's a lot of room to even improve further. Do you think data helps with that? Yeah, can the data help? Are we looking at scaling data further for this?
Yeah, that's a great question. So I talked a little bit about the scaling loss with respect to data in the talk, and don't see any signs of saturation yet. Um, uh, with that being said, yeah, it is a log linear plot. So adding another data point on that plot means an order of magnitude more data. Um, so and so that means there's this challenges that come with that. But this is definitely a path, one path, possible path forward. But another path is that scaling laws, just that we showed, just like any other scaling laws, they're pretty specific to the kind of model architecture we have, the training recipes, the pre-training that went in, and so on. So those scaling laws could look different for a different kind of architecture or with different kind of pre-training. So this is like maybe a good point to pause and then potentially explore that possibility before trying to push that further. Yeah.
Great. Thanks for taking the questions. Thanks for the very engaging talk earlier today. Thanks, Chay. We'll move over to Deepti. Deepti, great talk on metrics. This is always probably a very important topic for anyone working on generative video these days. How do you think we should think about combining different metrics into one single score? Is it even possible? Is it hard? Does it help? Or should the generations be evaluated along different aspects and keeping them separate?
Yeah, no, that's a great point. There are benefits to aggregating different axes and the metrics for different axes into one score, because that will help us optimize the overall model so that this one score is improved. But given the different aspects that we talked about in the talk, such as motion or object consistency and like visual quality and aesthetics, all of these are so subjective that it is very difficult to pool all of the different metrics into one single score. That would be definitely ideal, but it is very challenging. So at this point, it is the a good way forward is to think about some of these aspects independently, such as like overall visual quality. Um, is the generation obeying the laws of physics? Are the generations safe and fair? And making sure that uh, yeah, the overall generations abide by these core important fundamental like aspects. So that seems to be like that is a good path forward given the complexities.
And that's good to know. Now, like I think similar to what we were chatting with Chay earlier, can some of the generation challenges, like motion consistency you talked about, right, for video, that motion consistency is really important, which is very
Yeah.
different than what we have to think about for images. Can data help here? Can it be solved by more data or larger size models, or is it like a very different problem to be solved here?
Um, I think again the answer is somewhere in between. Data would definitely help because again we can show the model different instances of how the human like uh, actions such as walking or like um, yeah, like squatting, doing push-ups, all of these different like human motions should look like. And one way to approach this problem is like showing more evidence. Um, but also if we like take a step back and think about how we as humans learn to identify these different actions, it is not just through one modality, it is through a combination of different modalities. So I think um, data helps, but it is also important to think what kind of data should we expose the model to. Should it just be like more and more web videos, or should it be like additional cues that again like help the model understand the physics of the visual world and overall like learn better visual representations.
Great. Thank you so much, Deepti. Thanks for the answers today.
Thanks.
Let's move to Yunyang next on efficiency on SAM. Yunyang, you mentioned smart glasses as a possibility. It's crazy to think that we could fit in something like SAM into smart glasses. How much trade-off in quality you think one would have to do to fit something like, I mean, SAM too, into smart glasses? Are we talking about major trade-offs in quality there, or Yeah, we'd love to know more about that.
Sure. Yeah, I think this is a very interesting question. So we have been, thinking how to deploy foundation models to, to devices like mobile phones, like smart glasses. Not just about some, like also, Llama models. So for someone, this model, original one is pretty large. So we have to, reduce the model complexity for deploying to, smart glass. So it's always a kind of trade-off. If we remove too much the model size and improve the efficiency, we see some drop about the accuracy. So if we want to shift the model to smart glass, I can imagine like around 5% accuracy gap comparing to the baseline, but it can be running on device on frame.
Okay. That's very impressive. Thanks.
Sure.
It's amazing how much we could get into a little device like smart glasses. So, what about voice in the context of smart glasses? Is there like any other future potential with SAM leveraging voice and text prompts?
Yeah, I think this is also very interesting and hot direction, like even in academia. So how can we combine like different modalities for the final prediction? And we are considering how to add text prompt and also voice prompt because this is more natural comparing to click prompt and also box prompt or mouse prompt. So we have some ways to dealing with this, like clip model, but the encoder is still too large. So we still need to trade off the accuracy and efficiency by combining the text encoder to encode the text information, and based on this text information to give the final segmentation.
Got it. So you could specify masks through voice?
Yes, that's our goal. So we want to, just talk to, like, for example, like I want to segment human beings here, and I do not need to, click human beings or the target object. Just, ask to the smart glass, can you segment the human beings in the image? Then, the model can do that. This is our final goal.
Wow, that's very impressive. So I guess you'll need video understanding for those use cases. How good are SAM models for video understanding in general, like even for image? Because for masking, you probably need understanding of the scene, right?
Yeah, so I think this is a follow-up comparing to the adding multimodality for some prediction, for instance, segmentation, and we tried playing some image encoder for helping the image and the video understanding, but we found this model is more object level segmentation instead of semantic level semantic level understanding. And we compare with several recent vision foundation model like Dino V2 and Ciclip. And definitely like Dino V2 and Ciclip is doing much better than some for this case. And some can introduce much hallucinations. So we would like to see how we can, improve the some image encoder for video understanding and image understanding.
Okay. Great. Thanks so much, Yunyang.
Yeah, thank you.
Let's move to Z and Wen next. Maybe starting with Wen first. When you talked about performance features in your talk, what are the kind of importance of these performance features when we look at machine learning models?
Yeah, sure. We will send all the candidate features into the machine learning models, to perform ML model training, which we call it master cook. So the feature importance we are calculated as a byproduct of the ML model training. We will filter out those features with low feature importance score and retain the ones with higher score. The ones that are retained, in our performance signals signal candidates, like such as bandwidth estimations, video bitrate. They need to make it to the top 10% of all the features that are already used in the ranking model to be selected, as the features that would be implemented in the production. Yeah.
Okay. And so what are some of the pros and cons to utilize these performance features, like between rules and models, for example?
Yeah, that's a great question. So for rule-based system, we think it's easier to implement and it's more straightforward to understand. After all, it's just like some Boolean conditions, like if the bandwidth estimation is less than some threshold, then we will demote some heavy content like videos, and also it will be easy to figure out the causal relationship between these new features and the outcomes. So because we know that if there are some gains, we know that this features works because we only add this one rule. But for ML model, so it's a more formal methodology, and it could be more optimized by learning from the data. This is something the rule-based system lack of. However, for machine learning models, it's always hard to explain the model. Sometimes the model performance can be interaction results between the new features and the old features. And sometimes even the gains could be a noise. So it's very hard to do the attributions to our new performance signals. Yeah. So basically, we need to have a very careful trade-off between these two methodologies. Yeah.
Great. Thank you so much. Maybe Z, over to you next. What are some of the other features you think might be used in the ML models you talked about earlier? Are there other ones that might be interesting as well?
Yes, thank you, Abhinav, for the question. So I know in our talk, we mentioned about using device signals to improve recommendations overall. And some of the other features that we use are quality features. So namely, either the visual quality or audio quality of the content. So depending on the user's device, camera, or even network condition, the quality of upload basically varies across region, across device, across users, right? And we cannot simply judge quality of video by just resolution, but we actually use other models to measure subjective quality as well, which is basically answering the question of how beautiful is this video. So these are, how nice is this audio being played. So essentially, these are some other features that are really important that are being integrated into recommendations.
Thank you so much, Z. Very impressive talk, by the way. Moving over to Khawaja next. Khawaja, again, very engaging talk. It was good to see how your NASA experience and elemental experience coming in and still benefiting from to the video community. So when you talk of customer-facing metrics, is that the only thing we should be focusing on when we're looking at the ultimate viewer experience, or the other things are also important we should be thinking about?
Yeah, I think in the talk I talked about how focusing on just the internal metrics is not a good idea. And just like that, if you only focused on the customer-facing metrics, that's also not a good idea. You have to use metrics to compose an entire story. Customer-facing metrics like ZBR, time to first frame, capture, what the customers felt. The internal component level metrics allow you to determine how, to quickly root cause areas of improvements and what could have gone, what you could have improved if things did go wrong.
That's great. One of the interesting things is, as we are looking at latency as well as zero buffer rate. They're probably competing with each other a lot all the time. So do shorter segments actually impact ZBR?
They do. I think what happens is the media industry as a whole, we want shortest possible glass latency from the camera glass to the screen, and that drives us to have shorter and shorter segments. And there's a rule of physics essentially that come into play where if you are only, let's say, 10 seconds glass to glass latency, by definition, your player can only have 10 seconds of forward buffer, right? You're just not going to have more than that. So as the glass to glass latency shortens, the player buffer shortens as well. So that leaves even less room for, latency degradations and so forth that can cause the player to run out of the forward buffer. And you're going to be much more susceptible to the individual bandwidth spikes and troughs as well.
It probably could switch sooner, faster because of shorter segments.
You could switch sooner, faster, but there's little things like if you're using 6-second segments, you can get away with a failed request to the origin. And if you have to retry it, maybe it takes you 700 milliseconds. It's totally fine because it's a small fraction of a 6-second segment. But if you took away 750 milliseconds out of a 2-second segment, you're much more likely to cause an impact on players downstreams.
Yeah, that makes so much sense. I guess Netflix, a lot of people are talking about the Netflix live event it's pretty relevant to your talk as well. How could Netflix have benefited from zero buffer rate metrics? I think the question here asks for, can you walk through a practical deployable solution? I don't think we'll have time for that, but yeah, any insights on what could have been the benefit to Netflix with the ZBR metric?
I think I'll start by stating that I'm particularly proud of the Netflix team for what they pulled off. I mean, it was hard. Like they broke records, 108 million viewers. That is not an easy feat. This is one of the most streamed events in the country, and it is the role that the ZBR metric plays in events of this nature is that they let you capture the viewer experience and to methodically work towards improving it. So if the ZBR metric was captured, or a metric like that was captured, what you would want to do is, set this event as a benchmark and see how much that metric improves with the internal investments. Also, the metrics will inform what are the different components of the system that need to be changed. Sometimes things are very black and white, like it didn't go well or it went really, really well. But sometimes like ZBR really helps you collect as you fine tune when you don't have a lot of customers necessarily having a bad issue. You still want to be able to tell, like being able to go between 90% ZBR to 91% ZBR is very, very fulfilling, and it becomes harder and harder to detect that without having those concrete metrics. So if you start with the ZBR and then you have internal level metrics to figure out which component was at fault, you can really drive a lot of innovation and improvement towards the ultimate viewer experience.
That's awesome. Thanks so much for sharing. Let's for the next set of couple of questions, Ramzi, maybe you move over to you then. According to the presentation, what are the main advantages of using input videos pre-filters compared to developing, let's say, new codecs for improving the compression efficiency?
Thanks, Abhinav, for the question. I think there are a few advantages of having these input pre-filters. And the first one, I think these filters are codec agnostic, meaning they can work with any of the existing codecs without requiring development of new decoder. The second, sorry?
Go ahead.
The second advantage is the significant efficiency increase So in terms of compression efficiency, these pre-filters offer 6, 8, 10%. It's close to half a generational compression efficiency. And not only that, these pre-filters, they both run in real time and in VOD. So they are available for any type of workflows. And we spent some time into making these pre-filters objective metrics friendly. So when you use these input pre-filter for at scale optimization for your workflow, these pre-filters will not drop your metric or favorite metric for VMAP, for instance. And on top of that, these pre-filters have lower compute costs. So it's less than 20% on an ABC encoder or an JVC encoder.
Okay. And do these pre-filters end up with any cost savings for the CDN team here?
Yes, I think it's clear if, and I give the example in my talk. I think you can achieve a 45 terabyte of saving by reducing the bitrate at 1 meg. And if we take a video that is watched by 100K, I think there is a consensus that the cost of CDN is the bulk of cost when it comes to delivering events at scale. And any reduction on the file size without compromising the quality will lead to a substantial CDN cost reduction.
And so there's any compression efficiency difference as well?
Yes, I think the input pre-filter, at least the one I present is we did measure. I think the compression efficiency is around 6 to 8% in typical nominal workflows. It can go up to 15% if the content is noisy. But what we spent most of the time is conducting subjective comparison. And the idea is we wanted to make sure that these pre-filters do not degrade or remove the creative intent of the original videos. So we spent a lot of time doing subjective comparison using expert viewing. And I think the results of that is indicating an alignment of 6 to 12% compression efficiency.
Well, that's amazing. That's great.
Thanks.
All right, I guess that is all the time we had for today. Thank you, everyone. Thanks to all of you for sharing your insights to your video community and answering questions here. Thanks to all the speakers today. And this was our last segment for Video at Scale 2024. We appreciate all of you, our audience, for joining in today. We will be back again in 2025, same time next year. And if you look at the pace at which the video technology is evolving, who knows what would be the highlights in 1 year. But whatever it is, we will be there to bring those insights to you again. See you all next year, and have a great rest of the day today. Thank you so much.